Let's talk a bit about control statements. A control statement is code that controls what's executed later in your program or script. The most well-known examples of control statements are if-else statements and switch statements. Let's talk about if, else if, and else statements first. If-else statements in R rely on three functions: if, else if, and else. The if function can actually be used by itself. You can create an if function and decide whether something happens or not. The else statement must be used in conjunction with the if statement. If you don't have an if statement, then you cannot use the else statement. The else if statement must be used in conjunction with the if function and should be used with the else statement, though technically you don't have to have an else statement. But the reason you want to include an else statement is because if you don't include an else statement, there may be cases that you don't consider and actually introduce a bug in your code. An if or else if statement is used to perform a sequence of commands when the argument to the statement is true. On the other hand, an else statement is used to perform a sequence of commands when all previous control statement arguments are false. So if all of the logical statements included in your if or else if statements are false, then the code associated with your else statement is going to run. A set of if, else if, and else statements is going to have something like the following structure. We always start off with our if statement. We have the if function, we have a space, and then in parentheses, we have a logical statement. If the logical statement is true, then the code between these curly braces is going to be run. Notice that the open curly brace is always on the same line as the control statement, and then we have a closed curly brace that's in line with the starting character of the if function. Also notice that the code associated with the if statement is indented. This is good practice and it makes your code easier to read, so I recommend that you do it. After our if statement, we then start an else if statement if we want to start one. Notice that the else if function is on the same line as the closing curly brace for the if function. Is separated by a single space, and then after another space, I have my open and closed parentheses with another logical statement. If this logical statement is true, then the code between the open and closed curly brace of the else if statement is going to be run instead. Once again, that code is indented, which is good programming practice to make your code readable. Lastly, after my closing brace for my else if statement, or possibly my if statement if there is no else if statement, I start my else statement. So the else statement is going to be on the closing curly brace of whatever the previous logical statement is. I once again have open and closed curly braces, but I don't need to have a logical statement because I'm going to run the code inside these curly braces anytime the previous statements were false. And so we don't need a logical statement to evaluate. We know that we're going to run this set of code if the other logical statements were false. Let's use some control statements to do a categorization example. According to the Caregivers of America website, we can break down the birth years for the 7 most recent generations in the following way. The greatest generation is born between 1901 and 1927. The silent generation is born between 1928 and 1945. The baby boomer generation is born between 1946 and 1964. Generation X is born between 1965 and 1980. Millennials are born between 1981 and 1996. Generation Z is born between 1996 and 2012. And lastly, Gen Alpha is born between 2013 and 2025. So let's say we have a vector with a single birth year for an individual, and we want to identify the individual's generation based on the birth year of the individual. We can do this using a sequence of control statements. For simplicity, in our example below, we're only going to use 4 generations. We're going to use millennials, Generation Z, Gen Alpha, and then any other generation is simply going to be other. We start by setting a year variable equal to 1950. Now we're going to create a sequence of control statements to categorize the year variable into the appropriate generation. So we start off with an if statement here, and if year is between 1981, specifically if year is greater than or equal to 1981, and year is less than or equal to 1996, then we're going to set the generation variable equal to millennial. Else if year is greater than or equal to 1997 and year is less than or equal to 2012, then we set the generation variable equal to generation Z. If none of the previous control statements are true, we have another else if statement, and we ask whether the year variable is greater than or equal to 2013, and additionally, if the year is less than or equal to 2025. If that statement is true, we want to set the generation variable to gen alpha. However, if none of the previous statements were true, then we use this else function to specify generation equal to other. So I'm going to run that sequence of control statements and look at the value of generation. As expected, for a year of 1950, we get a generation value of other. However, this example would be a lot more powerful if we made a function to do this categorization. So we want to create a function that takes the year value as an argument and then returns the generation associated with that year. So in this set of code right here, I'm going to create the determine generation function. It is a function. It only takes a single argument year. I have the open and closed curly brace associated with my function. And then I simply copy and paste the previous control statements into my function. However, before I close the function using the curly brace, I need to return whatever I want the function to return. In this case, I want it to return the value of generation. So the function takes a year. It goes through the sequence of if, else if, and else statements to decide what generation the year corresponds to, and then it returns the generation associated with the value of year. So I run that code to create my function, and now I'm going to use that function to determine the generation associated with the value 1985. When I run that function, I get millennial, which is what we should have expected because 1985 is between the years 1981 and 1996. Before we move on, I want to note that both examples that we've done above are trivial and pretty unrealistic. So for example, our control statements don't work if we have a vector of inputs. So if we have more than 1 year, it's going to break. Additionally, it does not handle cases like non-integer values very well. So for example, what generation is 1996.5? That's between the millennial generation and the generation Z, at least according to our if, else, if statements here. Technically, that would probably be a millennial because it's still part of the year 1996, but based on the if, else, if statements here, that would actually get categorized into the other generation. So that would be another problem that we would need to consider. So with that being said, we certainly could improve the code that we wrote to categorize the year into the associated generation, but it does paint a picture of what can be done using control statements.